This is Neil Schneider from MTBS at GDC 2018. To my immediate right is Hiren Bhinde. Hiren is the Director of Product Management at Qualcomm. Welcome to the program.
Thank you very much. Welcome. Thanks for having me here.
So the last time, it's a pleasure. The last time I connected with Qualcomm, I saw the 835 Snapdragon-based head-mounted display. At least it was a prototype. And obviously, we got something new today. What have we got here?
So today we are introducing the Snapdragon VR 845 development kit. This is based on the latest processor from Snapdragon, which is Snapdragon 845. And this standalone HMD has not only new aspects to the hardware, but we're also introducing some cool new features to the software that's going to enable some new sort of experiences that the developers can create for end consumers to, let's say, have a much more immersive experience in VR.
Okay, very good. So why don't we hold that up? So now, when it comes to a head-mounted display, you have to, have tracking. We have to, of course, know how we're positioned in virtual reality, and there's different ways of doing it. Now, a lot of people are familiar with the PC-based solutions like the HTC Vive and the Oculus Rift, but you're doing something different here. Can you elaborate a little more as to how the tracking works?
Absolutely. So while the PC-based solutions have excellent tracking, one of the things that's required is external camera sensors, like what's called as lighthouses that you need to mount in two corners of the room for the right kind of tracking. So let me just quickly give an update. What does tracking mean here? Let's say I wear a VR headset and I'm in my conference room, or I'm in my bedroom, or I'm in a room, but when I wear the headset, I'm having an experience where I find myself in the middle of Manhattan, looking at the Times Square building in front of me, the Hard Rock Cafe to the right, the Disney store to the left, and I want to move around in that environment. That requires certain kind of tracking because the device needs to know that the user's moving left, right, front, or back. Now, for a PC-based solution, that's done with external sensors. The magic we're playing is because we are offering a truly mobile solution. No wires attached. You wear this headset, you put it on, and if you're using the same app, if you may, you would not require any sort of external sensors for tracking. There are two external facing cameras here, which are two fisheye lenses, and based on the algorithm that we've developed in-house, it could help move around in the environment. Last year on 835, what we introduced with the tracking was the algorithm based on VIO, or the visual inertial odometry, and this year it's going to be based on SLAM. So we're adding mapping capabilities, which allows the user not only to move around in the environment at the with the space of 1 feet by 1 feet, but this year it could be done in a living room or a big room around 20 feet. So that's something like a 20 feet by 20 feet, or whatever the developers customize it to be. And that's a pretty big deal for standalone VR. So that's something that we are introducing as one of the cool features on Snapdragon 845.
Okay, but there's other cool features as well. I understand you have a new relationship with Tobii Technology. Can you elaborate a little bit more as to what Tobii Technology does and why this is important?
Absolutely. So one of the cool features of VR is eye tracking. And what is eye tracking? So let's say you're wearing a VR headset. There are IR LEDs inside and two cameras that are continuously tracking where your eye is looking at. Now, why would one need to track the eyes? It's pretty simple. Let's say you're playing a game in VR and you want to select a menu option. There are 5 options in front of your eyes. You just want to look at something and want that option to be selected. That's one application. Second, let's say 2 friends, one's based in New York, the other friend's based in Sydney, and decide to have, say, virtual coffee at a lounge in a Paris kind of a lounge, and they want to meet there. When you meet in a social, in a virtual environment, you actually want to make sure that you're really looking at each other. There's a lot that's communicated through words, but there's much more that's communicated through eyes, and that's something that could be enabled by eye tracking. Last but not the least is with eye tracking, there's something called as adrenofoveation plus eye tracking. Now, what that means is foveated rendering, where let me just give you a quick overview of that concept. When we look at the world, when human beings look at the world, they are actually only focusing at this thumbnail area. That's where the focus is. The fovea is just focusing at that. So let me go back to the example of the Times Square building. If I'm looking at the Times Square building, I'm actually focused only on the building. But I can still see the rest of the New York, the tall buildings, the cabs going by, but my focus is just on one piece. What can be done here by tracking the eye position and focusing or putting only that particular area in high resolution, you could have the rest of the area blurred, and that's how it saves the power consumption of the device. Now, we've all used smartphones, and nobody likes when the smartphones become hot. Now, imagine a device being closer to your eyes. Nobody wants the device to get hotter. And that's why Qualcomm takes it extremely seriously in terms of power and thermal management of these devices. So the combination of adrenofoveation and eye tracking helps keep the power management and the thermal dissipation of the device really low. That's where Tobii came into the picture. Tobii had this technology of eye tracking, and they're dominant leaders in the world of eye tracking. And Tobii and Qualcomm, it was the perfect marriage, if you may, for Qualcomm's processor with a cool, not only the hardware design ID, the reference design, the dev kit that we were building, but also the software development kit that we had, along with Tobii's integrated eye tracking technology, is going to do wonders for consumers to have different sort of inputs, developers to provide different sort of experiences, and of course the device makers to make sure that the power consumption is really low.
So it sounds to me like the big advantages here is, first, from an experiential point of view. Like when you're using eye tracking, the content can interact with you in other ways. Like, let's say you're in a game, based on what you're looking at, perhaps the other characters are looking at the same thing. So they're interacting according to what your eyes are doing. And I gather there's that performance benefit with foveated rendering, where you're just, all that processing power is concentrated on where you're looking versus the whole scene. So that's really, really something else. So now, the last time I interviewed Qualcomm, we were looking at the 835 Snapdragon series. This is, of course, the 845. Okay. Are there products lined up for this yet, or is this still like a prototype phase, release?
We are in discussions with several partners and OEMs right now, and I cannot disclose more, but you will see some announcements, if you may, in the future. Okay. But yes, we do expect some exciting devices to be built based on Snapdragon 845 in the future.
Well, I would hope so.
Yes, absolutely. We're very excited. We are actually very excited because it's just 2 years ago we introduced a standalone VR reference design for the first time, and a VR development kit which would help you look around the world. Last year we moved that experience to not only looking around the world, but being able to move in the world at least up to 1 meter. Now we're introducing a device that helps you move in a big room. So we're pushing the technology envelope, and I think it's we're really excited with what's going to come next as well.
Now, another question I have now, these cameras are for SLAM, they're for inside-out tracking, positional tracking. Can they be repurposed as like pass-through cameras as well? Is that on the roadmap as well?
We are looking at several options on how to optimize different sorts of cameras for different functionalities, if you may. We are investing a lot of time and research into that, because we do see advantages of the combinations in which the cameras can be used. At this point, I can only share that.
Okay. And from a content creation point of view, I mean, it is advantageous to have your hardware in all of these different vendor products, be it Oculus and HTC, and you've got your own stuff going on here. Is there an SDK to support it all? Like, is there consistency from one platform to the next? Are they individualized? How would you describe it?
Absolutely. So let me first answer the question for this dev kit itself. The Snapdragon 845 dev kit is going to be shipped with HTC Vive's Wave SDK later part of this year. So for the first time, we are actually going to be shipping our dev kits with the Wave SDK integrated. So we're very excited about that partnership with HTC as well. Second, as far as the different ecosystems are concerned, we are extremely proud to be a part of an industry where big companies like Google and Oculus and Vive are investing a lot in developing this content that could be used from device to device. As far as having a uniform SDK, that's, I think, we'll see how the future works out.
Okay, wonderful. Well, thanks so much for joining us. Really cool stuff.
Thank you very much. Really appreciate it.
This is Neil Schneider from Meant to Be Seen at GDC 2018. We will, of course, be back with more. Thank you for watching. Thank you.